Hello, my name is Matthew Clay. I'm Chief AI Officer at SingularityNet. This is a closeout report for Cardano Catalyst Fund 7 under the campaign for AI and SingularityNet, a $5 trillion market. Our project was for an AI domain-specific language. So first of all, a little bit about their long-term goal in creating an AI domain-specific language. What we're aiming for is to create a system to automatically discover and connect available marketplace AI services on the SingularityNet platform to solve a particular given real-world problem. We did phase 1 in 2021. For phase 2, we broke our proposal down into 6 main tasks. We did not get back to work on our ontology tasks. We did not continue exploratory smart contract tasks any further. We had done quite a bit in phase 1, so we weren't too worried about that. Since we didn't complete all of our tasks, though, we didn't get to production tasks either. Nonetheless, we did quite a bit of work in registry, test cases, and in coevolutionary tasks. So I'm going to talk a little bit about the test cases because when we put our proposal together, NewNet suggested that we could work on their fake news warning app. After being awarded funding for Fund 7, we learned that NewNet had abandoned the fake news warning app. So we came up with the idea of instead concentrating on fundamental machine learning algorithms. This includes optimization, descent. A specific implementation of that is gradient descent. Other foundational algorithms are linear regression and logistic regression, and what we call a logistic linear regression, which is logistic regression that relies upon linear regression in order to really build this composition of services together. So some of our key achievements in phase 2, when we first came up with the idea of descent as opposed to gradient descent. How do you know that an algorithm is descending? We actually wanted to show proof of this. So we formulated property and formally proved the descent property. And this will allow for eventual autonomous interoperability of AI services. Some other key achievements, we explored 4 approaches to program synthesis using our own language framework, using IDRIS elaboration and reflection framework, using IDRIS API for interactive type-driven program, as well as an intelligent coevolutionary intelligent agent market simulation. For next steps, we want to wrap the 5 AI services that we built into actual SingularityNet services, continue working on the registry prototype for composition and verification of compositions of services, formalize, improve additional properties, and define the syntax of the AI DSL language itself. Here, we really want to distinguish between power users and those users who want ease of use and just want something that works. Some additional steps that we want to take is how do you integrate crisp mathematical properties with uncertain ones? And we also want to look at integrating additional properties, having hardware considerations within smart contracts. I'm going to leave with Nil Geisweiler, who's going next to actually demonstrate some of the working code that we developed.
For that phase, we have implemented real AI algorithms using a dependently typed language called IDRIS. These AI algorithms were selected because they are well known and they are tightly related to each other. So here's an example of linear regression with a simple dataset to fit. We can run this example and we obtain a linear model as solution. The interesting part, however, is that since we're using a dependently typed language, we can specify properties characterizing these algorithms and use these properties to automatically connect these algorithms together. In this work, we started with a descending property, expressing that the optimization algorithm should descend. Such property constitutes a simple example of formal description of AI services. One would need more properties to fully describe these algorithms. However, Once we have defined these properties, we should be able to use them to compose new AI services. But for that, we need to solve the problem of program synthesis. We are exploring a number of ways to do that, and I'm going to show one particular way. I have a gradient descent service, and with that, I would like to synthesize linear regression. So what we're going to use in this example is a functionality that has been recently introduced in Idris called proof search. To do that, we're going to introduce a meta function, and in argument, we're going to provide all the functions we would like the synthesizer to attempt to combine. Here we have what is called a whole, and Idris offers a number of solutions. We're going to select this one, which is the one that we wanted. As you can see, it's simpler, but it is getting there.